Okay, so now we are doing waves. Waves are a thing in which energy is transferred without matter being transferred. So when you see a wave like moving around, it's gonna look like it's going here, but the matter, like particles, they aren't actually moving that way. They are only going up and down. Only that. However, energy is being transferred. Now there are two types of waves. There are longitudinal waves and transverse waves. Okay? The longitudinal waves, let's say we have a spring. This is a spring. Basically, it'll become thick and thin. As you can see, bad drawing, but the spring is going this way, and it's becoming thicker here, and then extending out again. And on the transverse waves, it's going to be like, yeah. So here these are called compressions, and these are called rarefactions. The distance between two compressions here is the wavelength. And here the wavelength can be the distance between two peaks or two troughs. These are peaks and these are troughs. The height of a wave above the here normal sort of is called the amplitude. And there's also wave speed, which is how fast the wave is going. Now, the longitudinal waves, it just goes backward. The particles go backwards and forwards to a certain extent, and that's it. They don't actually move. And here, they just go upwards and downwards. And again, they don't actually move, right? Yeah. I just have a bit of a cheat sheet here to make sure I don't forget anything. Yeah. This peak here is also called the crest, by the way. Now, there is a formula for all waves. There's a formula. Like everything, there is a formula. The formula, I'll just draw the formula triangle. V and so V is equal to F times this. Now, V is the velocity, the wave speed. This this is the frequency measured in hertz. And this is the wavelength. This is in meters. This will be meters per second. Yeah. Yeah, so there are also many different types of waves. Some types they're divided into transverse and longitudinal. For transverse, we have light. We have the earthquake S waves. We have the waves in water, and we have all the radio waves and everything. For transverse we have sound and earthquake P waves. Okay? Yeah. Now, what are we doing next? Now we will look at some light. Now, light is reflected in mirrors. So let's look at ray diagrams, which basically shows us how light is reflected. So say this here is an object. What? Oh my days. Sorry guys. Say that we have a here object and we have a here mirror. In the mirror, the non-reflective end always has like here. So this idiot. So everything reflects light. So when this object here reflects light, it will reflect back. Now here in between the object and the reflected ray is the normal. The angle of incidence, this one, and the angle of reflection, this one, are always equal. That's a main rule. The angle of incidence and the angle of reflection are always equal. But now, where is the object? The next point is, where is the object? So now, what we need to do is we need to pull back the line of reflection. This is going to be a dotted line, I kind of forgot. And when it's been the same distance as that, there is going to be the object. And now the distance from the mirror is the same as the distance from the mirror here. And this is your eye, by the way. Yeah. So what if we have a larger object? If we have this an arrow, we can easily show this. So say we have our mirror and we have an eye. So one ray goes here. Ray goes here. I'm sorry, I'll just straighten that. Oh damn. I don't know what I did here. And one ray goes here. Since the angles are the same, it'll go like, oh my god, here, and this will go here because the angles are same. Now if we draw back the lines, it'll take a while, but eventually they will converge here. This one will be here, and they will not converge. It will create the same line. Yeah, and then there's also lenses. Lenses is basically a piece of glass allowing light to pass through. This is a convex or converging lens. So if this is an object, light goes, light goes, light goes. The light will all converge here. Now there's a variety of diagrams for this. So um if it's further from the focus, it's diminished. Basically you need to experiment around. Let's This diagram represents a lens. If it goes straight in, then it'll come out at the focus. If it goes from here to the center, it'll go straight. If it goes here, no, no. If it goes from here through the focus to here, then it will come out straight, and now we have a point here in which we have the same point. Now, depending on where you place it, depending on focus and to focus to, that'll determine the size of the object. Also, there's dispersion of light. If we get a triangular prism and white light goes in, the rate of the light slowing down will cause all the colors to separate. So that is going to be the colors of the rainbow, which happens when rainbows form because the raindrops act as a separator. So the colors are red, orange, yellow, green, blue, indigo, and violet.